There's current on this pole ground, and nothing is wrong. I've seen a lot of discussion about the system neutral and grounds lately. Let's get into it. At a house, neutral and ground are two different wires with two different jobs, and at the top of the pole, that debate doesn't really exist. The neutral is the ground. It's tied to earth at every point and at least 4 times a mile by code, but really typically every pole and everything on the pole bonds to it. Equipment, grounds, arresters, all of it. One big web connected to dirt over and over again. So let's start by asking the obvious question here. Why are there measurable amps on grounds? Well, current doesn't take the path of least resistance. That's a myth. It takes every path split by impedance or resistance, and most of the unbalance rides the neutral home. But part of it is always finding its way home through whatever path it can, taking alternate routes the more the neutral or its connections degrade. Amperage on a pole ground can be normal, but should be minimal. So why does the neutral carry the loading imbalance? Well, because everything on it is pulling or pushing against something else. At your house, your two 120 volt legs push through the neutral in opposite directions, so it only carries whatever doesn't cancel out between them. The same thing on the feeder. 3 phases 120 degrees apart and equal loads cancel each other out to zero. The neutral is quietest when the system is balanced. Every light that flips on, every non-balanced tap up and down the line lands on it, and that's the current on the neutral. Nothing is wrong, just the system doing its job. So why does everything up here share one ground and interconnect? Well, fun fact, we tried it the other way first and it went badly. Back in the 1920s, a Potts lightning arrestor had its own individual ground rod and the secondary neutral was grounded separately. When lightning slammed tens of thousands of amps into that one ground rod, the whole primary side of that pot jumped way above the secondary for a split second, and that difference created stress across the insulation between the windings. Pots were failing due to lightning all over, and in 1932, Purdue and the Chicago utilities proved that bonding the arrestor to the secondary neutral cut that surge voltage by up to half for 2 reasons. First, with everything bonded, the whole pot rides the surge as one piece, so the insulation never sees stress from the difference. And second, back then that secondary neutral was the best ground on the pole. It tied to almost all customers' water pipes, miles of buried metal, while the arrestor just had one lousy ground rod. That's why now your arrestor's ground connects to the tank, and the tank connects to the X2 neutral, and everything's connected. And here's the part that bites. All that bonding is why an intact neutral is safe to touch. Grab it and you're in parallel with miles of ground references and unbalance. But cut it under load and put yourself in series, the current does not stop. The voltage across that opening climbs to whatever it takes to keep pushing current through the dirt. A couple hundred volts on a good day towards primary voltage on a bad one. And up the line, the neutral is carrying every customer's unbalance at once. So always mac out a neutral before you cut it, and treat a broken one like it's hot, because it might be. That's part 1 of the how and why behind the system neutral and grounding. So follow along for the rest. Tell me how your outfit builds it. Does every pole get grounded? Does every transformer get a ground rod or maybe a butt plate? And if you want the hows and whys behind everything else on a transformer, that's in my app, XFMR Lab. Stay safe, boys.